Hi everybody! In today's lesson, I want you to be able to identify the sides and vertices within different 2D shapes. So in order to be successful, you're going to need to count the number of sides in a shape. Success criteria 2 is to be able to count the number of vertices in a shape. So remember, vertices are the corners. One corner is a vertex, and more than one corner, we call it vertices. And finally, success criteria 3, you're going to need to be able to explain whether the number of sides and vertices change if the shape is drawn differently. So let me show you how you're going to do that. The task on the class page looks like this. You'll see that you've got different shapes down the side, different 2D shapes. First of all, you've got to recognise what the shape is and write the name of it. So for this shape here, I know that that's a rectangle. So I'm going to write the word rectangle in this box. In the next column, you'll see it says sides. So here you're going to count the number of sides in this 2D shape. Let's count. 1, 2, 3, 4. Remember, sides are the straight lines in a 2D shape. So there are 4 straight lines in a rectangle. So I'm going to write that in this box. Now you'll see the next column says vertices. So I need to count the vertices, the corners, in a rectangle. 1, 2, 3, 4. The next column says draw another type. So this is your challenge to try and draw a rectangle that looks differently to this. So it might be that you change the orientation, which is the way in which it's drawn. So this rectangle is drawn so that the longer lines are horizontal this way. You might draw your next rectangle so the longer lines are vertical this way up. Let me show you. So as you can see, my rectangle here looks different to the rectangle here, but it's still a rectangle. So now my challenge is to see, has the number of sides and vertices changed? So we're going to fill out the number of sides in this column here. So let's count the sides again. 1, 2, 3, 4. 4 sides. And let's count the vertices to put in this column. 1, 2, 3, 4. So we know that in any type of rectangle, whether it's drawn like this, or however it's drawn, it will always have 4 sides and 4 vertices. So the reason for drawing it out again in a different way is so that you can see, will the shape still have the same number of sides and the same number of vertices? And that's the question that I'd like you to answer at the end. There is a challenge. There might well be one shape that you cannot draw in any other way. I want you to see if you can find which shape that is and try and explain why. Why can you not draw it in any other way? There will be bonus happy marks if you can explain why. When you get onto these shapes, you might have to look up the name of the shape if you can't quite remember. The trick is to count the number of sides and then you can research what the shape is called if you can't remember already. Try to predict what you think the shape is and then research it. For example, this shape, I'm going to count the number of sides. 1, 2, 3, 4, 5, 6. There are 6 sides, so I'm going to put that in here. And then if I wasn't sure what a 6-sided shape was called, I could look it up on the internet. The internet tells me that a 6-sided shape is a hexagon. So this shape is called a hexagon. So then I would fill in the number of vertices in this column by counting up the number of vertices. Now here I've got to draw another type of hexagon. This is what a regular hexagon looks like. A regular hexagon always looks this way. But you can have other types of hexagons. It doesn't matter what they look like as long as they've got 6 sides, because a hexagon always has 6 sides. So I could draw any 6-sided shape here. Here is my hexagon. Let's count to double check it's got 6 sides. 1, 2, 3, 4, 5, 6. Yes, it does. So that, even though it doesn't look like this, it is a hexagon because it's got 6 sides. And then here I would count up the number of vertices and see if they were the same. So again, remember, you're looking to see if the shape is drawn differently, but it's still that shape, whether it has the same number of sides and the same number of vertices. Good luck, everybody. I can't wait to see what you find out.